Hey everyone, hope everyone's good. This is Strategies for Low Carbon Cloud Architecture, and I'm Kamar Ali. So before we get started, I just wanted to give you a little introduction to myself. I'm 28. I've been working in industry for 7 years now, since I was 21. Yeah, good maths. I graduated from Newcastle Uni in 2016. Whilst I was there, I did a couple of jobs. I worked in a kebab shop. It was a really poor Photoshop of me doing that. And I also worked in a warehouse. I couldn't be bothered doing the Photoshop there. I then worked at NCC Group for 2 years out in Manchester. That's where I'm based. I then moved over to Raytheon UK and did a bit of work with them for a couple of years. And then I decided I wanted to move down to London and join Capgemini. I had no idea they were a consultancy. So I get there, I get the job, everything's good. I then turn up and they're like, oh, you're in Bristol. I'm like, what? I moved down to London. So yeah, long story short, I'm still here, which is good. I actually now work in London, but live in Manchester again. Long story. Anyways, so I just wanted to quickly go over what this isn't. This isn't going to be me giving you you should do this, you should follow this, you should definitely do this. This is more to get you all thinking about the work that you do, the tech stacks that you use and your projects and how you might be able to implement some of these things. And everyone's going to be different because everyone's made different mistakes. This isn't going to be throwing paint at paintings or soup or tying ourselves to roads. I think that's in room D. I'm not entirely sure. But yeah, I want to get everyone thinking. I want you all to think about your stuff and your work. So whilst I'm talking, if you want to ignore me, go on your laptop, that's fine. Look at your tech stack and think, oh, you know what, actually we can do that. And then at the end, if you want to come and talk to me later and say, oh, we've got this, this and this, and we can discuss it. I'm by no means a subject matter expert. And to be honest with you, I'm actually kind of surprised I'm stood here today. So this is my first ever talk ever. So if I do a lot, I'm sorry. I'll get better. Did it again. So this all kind of started last year in November. We have a thing called calibration at Capgemini in our group. There's about 120 engineers in our area, and what we do is we essentially summarize everyone's entire year onto a piece of paper. So you've kind of got work you've done with your client, work you've done for our team, some training that you've done, so if you've done an AWS cert, and anything else. And what we essentially do is we put all of these things on the wall and we'll rate everyone and say, right, this person's been brilliant, we're going to give them a 1, or this person hasn't turned up for work at all this year, so we're going to give them a 5 and probably fire them, but that never happens. And one of our objectives for the year, which was handed down by, I don't know, someone up in corporate, was being sustainable. And the idea of being sustainable is Capgemini want to be carbon neutral by 2025 for all business, operations. So I'm guessing that's stuff like traveling and I don't know what else. I didn't really care, to be honest. I was like more corporate stuff. I do care about the environment. I recycle, I turn my lights off. I care, I guess. But it just felt really forced. And so I waited till end of year and was like, oh my God, what have I done? And it actually turned out I had done something. So my old tech lead's in a room, he sat there, and about 2 years ago, we had to set up this Kafka Mongo cluster, Mongo cluster, Kafka cluster, and Kafka needed Zookeeper. The idea was it was going to spread over 2 regions. And so we ended up having 9 boxes. So we had 3 Mongo, 3 Kafka, 3 Zookeeper, and we had all the Ansible and Terraform scripts and everything was golden. It was fine. We brought that back up to our client and everything was cool. Fast forward like 9 months and someone's like, we need the same infrastructure for our dev environment in AWS. I'm like, I can solve that in 2 minutes. Bang, done, jobs are good. And so we have 9 boxes running. About 3 months later, so last summer, somebody comes to us and it's like, guys, you're spending 3K on AWS a month. And we're all like, what? What do you mean? Like 3K? Take a look, there's 9 boxes spinning. One of my colleagues, Jack's like, we can just run these Docker containers on one and job's done. So that's what we did. And then it comes back down to me filling in my form, saying what I've done, and sustainability. I'm like, I did this great thing where I, minimized our infrastructure used. And then essentially that kind of got the cogs ticking. But up until that point, I hadn't really made a conscious effort, to be quite honest. Sorry, Sarah. So I decided to take a look at everyone's pieces of paper on this wall while somebody was having a heated discussion around somebody doing some training. And I wanted to just share a bit of the feedback with you that was on these. So this is sanitized and it's out of the 68 people I was able to get hold of. So for this sustainability objective, 23 people said that they use public transport on their thing. So please bear in mind that we're engineers here. And so there's a little bit more that we can do. That's all they could come up with. 44 said they could work from home, which is quite lucky. Not all of us can, or not often, and that's really cool. Another 5 said that they bought a new electric vehicle, which I guess is nice. Only 4 of us recycle, apparently. Yeah, I didn't know what to say to that. We need to recycle more, Capgemini. One person didn't use their heating all year, which, yeah, fair. I hope you're okay. And then 6 people decided to say no to printing, which is, to be fair, probably a little bit more work related. I don't know which program is printing or what you're printing. One person, to help Capgemini's business interests, went vegan. Once again, being vegan is really difficult. My ex was vegan. It's not easy. I can get why you would, but it doesn't quite hit that mark for me anyways. And then another person decided to go litter picking in the Thames, and we haven't seen him since. But he did go litter picking in the Thames, and so he did his bit. And then a few other people actually did some related stuff. So this is reducing my brilliant piece of work. So 5 other people reduced a number of unnecessary resources. So turning off boxes on weekends, that kind of thing, all in the cloud, whatever they had to do and whenever they had to do it. 3 people worked on sustainable architecture, which we'll kind of touch on in a little bit. And then a couple of other people worked on efficiency monitoring tools. I can't read my own handwriting. So looking at things like Spring, Quarkus. So there was a talk on it earlier. I didn't actually make that because I went to the wrong room and just sat down. Yeah, so anyways, I leave this calibration session. This is in Birmingham, by the way, so I'm getting on the train to come back to London. And I get on the train and I'm like scrunched up because everyone's on there and somebody's hugging me and it's really weird and it's really full, and I get my phone out and I decide to Google sustainable software engineering. And I essentially just opened Pandora's box and was like, oh wow, there's a lot here. There's more than I thought. There's a whole practice. And the first kind of stop you come to is the Green Software Foundation. So they essentially give us some core principles, and then off that some patterns, which I'm going to show you some of the patterns I've, 1, come up with, and 2, stolen from them. And then 3, practices. So that's companies, so like your own companies, your Googles, your Amazons, your Facebooks, whoever else does software, what they've done to implement these things. I think this pyramid should be the other way around, because the principles form the foundation of everything else that you do. So patterns remain in the middle and your practices are kind of the end of it and what you've achieved through that. So here's our principles. There's 8 in total. I'm going to kind of cover them all really quickly. Some I'm going to stick onto more than others. So there's the idea of being carbon efficient. There's the idea of being efficient with electricity. There's the idea of understanding carbon intensity. There's the idea of embodied carbon and your devices and the carbon cost of them. Energy proportionality, networking, demand shaping, and then optimization. So carbon efficiency, this is the idea of understanding that everything we do has a carbon cost. Like no matter what we're doing, and like even this presentation has a carbon cost. So if we've got a 5-litre Ford Mustang and a Nissan Leaf both traveling 1 mile, I'm guessing the Mustang's going to have a higher carbon cost than the Nissan. Or not necessarily, but more than likely. And the reason not necessarily is because we have to understand electricity and the fact that even though electricity feels clean, and then everyone's like, oh, I've got an electric car, it's brilliant, something still has to generate that electricity. And so we have our renewables. So we've got wind, solar, biofuel, hydro. We've got clean energy, so nuclear, dangerous but clean, I guess, depending on where you sit on that. And then you've kind of got your dirty energy, so coal and gas. And so actually, it might turn out that Nissan is using entirely coal-powered electricity, and so you might as well look cool whilst you're racing a mile, as opposed to trying to save the planet. And that kind of brings me on to the next point, which is carbon intensity. So this is the idea of electricity and what it's made out of. So you've kind of got on the left-hand side here, so imagine today, say it's really windy and sunny outside. I think it's sunny, might not be windy. Whilst that is happening, the carbon intensity in the electricity grid is lower because we're burning less coal and gas to produce electricity. And so at midday, it was 120. However, 10 p.m. tonight, we still have the same demand. People are still powering their lives. We don't all just turn off for the night. And because the sun has stopped shining and it's decided not to be windy outside, the carbon intensity of the grid becomes a little bit higher. Some of my demos later will kind of explain that. And that leads nicely into demand shifting and demand shaping. So if you imagine on the left-hand side where it says resource, this is just nicked off Google. I think, I can't remember. On the left-hand side, the higher that line is, the lower the intensity is. So it's kind of an inverse flip. So as the carbon intensity in the grid is lower, I know this isn't a very great diagram for this, we want to do more work. And then as it gets higher, so as the electricity becomes dirtier, we want to do less. So it's the idea of knowing when we can do that. And there's a bunch of things we can do, and there's really cool tools online, which is what I'm going to get into later. But the idea is we can do some really, really, really cool stuff to run certain workloads at certain times. So there's two ideas. There's the idea of demand shaping, so what I've kind of alluded to, so controlling what we do and where. So really cool example I have, or I thought of anyways, probably stole from somewhere. Say it's Black Friday's coming up, but nobody ever just does the day. Everyone does like weeks in advance. We can look at certain parts of Europe, for instance, to say we're selling trainers, and we're looking at selling in Germany. We can pull up a weather report for the week and kind of say, okay, it's going to be really sunny on Wednesday and the wind's going to be blowing. So knowing what we know about Germany's infrastructure, we can determine that the carbon intensity is probably going to be low. We can't put a number on it because we don't know. Nothing exists right now to predict that. I don't think it does anyways. But we can use like little bits and bobs to kind of work out when we're doing something. So we could decide to sell in Germany next Wednesday. And not only is our API, which is now running in Frankfurt, so I'm thinking AWS here, so it's like EU Central 1 or 2 or whatever. But the users who are also plugging in to buy these trainers are also using cleaner energy as well. So we've kind of shaped when that happens, as opposed to saying 9 a.m. tomorrow. I don't care. So we've made an impact while still achieving our business goals. And then when and where, so I've kind of covered the where there. The when is looking at intensity and when it happens. So if we have to run in London for whatever reason, there's a really cool API, which I'll touch on later. And we can decide when we run our workloads depending on what we're doing. So it's not going to work for everyone and everything. If you've got an API, you kind of need to be on all the time, but you might have a job running in the background. You can choose when to run that. I'll get onto that later. So this embodied carbon. So this is the idea of our hardware. So I've got a laptop here, which is like 4 years old and I hate it. And the amount of carbon that was used to produce this laptop. And it's understanding that that's always going to be greater than the actual usage. So I can use this to my heart's content, but because of everything that went into building this, it's always going to be a heavier cost. And so it's trying to extract that usage out of that hardware. So if you've got like a server, if you're still not in the cloud or whatever, and you've got your own servers and you're deciding to get rid of them every 4 years, can you repurpose them? Can you run them for more years? Is there really a business need to scrap them? And if you are going to scrap them, don't destroy them. Like, yeah, maybe remove the hard drives, but I'm sure someone somewhere will buy them. Same with laptops. Like, there's, I can bang on loads about how, people all over the world would love a free laptop, and so on and so forth. So definitely trying to get use out of things. Dev machines as well, if it works, and just because you want a fancy MacBook which has a full screen, do you really need it? Maybe, but most likely not. So you can dev on the older one for 1 more year. I used to change my phone every 12 months because I just wanted a new iPhone. And then after a while, I was like, I'm just wasting money more than anything. That's fine. I've had it 2 years now. I, probably will keep it for another 3 or 4. There's energy proportionality. So this is understanding that we, up to a certain amount, up to a certain utilization of our hardware, the electricity cost is quite high, but then going beyond that, it's quite low. So if we have 4 or 5 servers running, one's running at 50% and the rest are running at 20, actually moving those 20s to be on a combined server or moving some of those workloads onto the one that's running at 50 is going to be more efficient than spreading that usage. And so I understand that we need to have redundancy, but maybe leaving things off or in a state where they're on standby as opposed to leaving them on and running all the time is better, because the idea is that the CPUs are there to be used, and so not using them is almost a bit stupid, or we're just not utilizing that, and so we need to actually make more of an effort to use what we have. And then there's the idea of networking. So this is kind of 2-pronged. The first is data. I usually work with APIs, and we'd send big data packages off and back and forth and this, that, and the other. And the idea is, are we sending unnecessary data? So the best analogy I have for this is if we're going camping and I've got a sleeping bag, sleeping mat, cooking equipment, change of clothes, all that stuff. Do I also really need to bring my laptop? I'm just carrying extra weight. There is literally no point. I'm not going to have time to sit in my tent and watch Netflix, and probably not have signal either. So the idea of not sending unnecessary loads, because essentially they will have to travel, meaning there is a carbon cost of sending that data. So if we can trim things down and work with our APIs to ensure that they are like smaller, more concise, and actually just get to the point and give our users what they want, is better. And then there's the idea of sort of distance and like traveling. So if we are creating a web app to serve the whole world and we only deploy it in London, like, yeah, everyone in the UK and Europe's probably going to be fine, but all the data traveling to like, West United States is traveling a long way. It's going to cost a lot, and our users are going to be really annoyed because it's going to be really slow. So there's those things to keep in mind as well, like making sure that, we're deploying in multiple areas when we need to, because essentially that's going to be cheaper and be more effective than sending data halfway across the globe all the time. And then finally, there's optimization, and this is kind of a catch-all for everything else. So one of the things I instantly thought about when I first opened this box was, you've got a database query, you get your data out of the database, you then use a programming language to filter on that data, send it off. There's almost no point usually for that middleman. Why not update your database query or write a different one? They might serve two different purposes, I don't know. But doing it once as opposed to twice is always a good idea. And then another one, and my reviewee, I hadn't actually met him until last week in person. So I went down to Bristol to see him, and he said, so I've given this and these last 9 slides before, and he said this, so he's an F1 fan, and he said this slide he completely switched off at this point and kind of dwelled into his own world and was thinking about some of the stuff him and his team do. And so they've all got EC2s that they kind of RDP into every day for work reasons. And they've got a schedule on it, so it'll run 9 till 5, 8 till 4, or whatever crazy hours people do. And one of the things it doesn't do is, what if someone's on annual leave? What if there's a bank holiday? So one of the things he's been working on is working with their calendars to essentially turn those off when people aren't in. So on Monday, he knew all their machines would be popping up for no apparent reason. Nobody's using them. What's the point? That's an optimization. Obviously, if someone's ill, you can't predict that, but somebody can just go on and turn it off at that point, or some other crazy tool might do something. So hopefully you've all been thinking about your stuff whilst I've been talking, I hope, and just thinking about the changes you can make using those principles. There's the Green Software Foundation online. I can share the link. I've got a couple of QR codes at the end. I forgot to add it in, which I just remembered. So I will share the link. I'd highly recommend their content because it goes into a lot more depth than I did and probably explains everything a lot better. But yeah, so my first demo is about not carbon intensity. It's about, it's carbon intensity and scheduling when we run something. So the idea behind this is we're going to work with an API created by when I find my mouse. I've just realized I'm not sharing both screens, am I? Give me 1 second. How am I going to do this? Sorry, I didn't. I kind of thought I was sharing both screens, but I'm not. This is going to be difficult. So this is the National Grid. They did some stuff with Oxford Uni and the WWF, not the wrestlers, the pandas, to essentially create a carbon forecast tool for the UK. So it gives us an intensity for today. So I don't know why I'm pointing at that. An intensity for today. So that's an average for today with the highs of 244 and 159 as the lowest. It's almost like a weather report. It's really cool. And they've got a really, really cool API, which essentially can give you that forecast for the next 48 hours. It's not massively accurate. Well, it is. Sorry. It's not always accurate, I should say. So earlier today, they forecasted that the carbon intensity would be at 186. It turned out it was at 211, 204. But those lines do follow each other. So it's pretty accurate. It uses machine learning. It does use stuff like weather reports and that kind of thing. And then the WWF did a really cool thing where they used that information to kind of tell people when to plug and unplug. So really, fortunately, my talk fell into a time when they tell you to plug in. So actually, this is as least carbon intensity it possibly can this talk, which is quite cool. That's pure luck. I did not plan that. I was quite chuffed with that when I saw that. And then they also give us regional data. So one of the things we can think about is, do we have data centers in London, and then do we have data centers in the Northeast? The energy there is so much cleaner than it is down here. So if your client or whoever you're working with do have data centers, if there's something in the Northwest or Northeast, potentially thinking about running most of your work there might be a little bit more beneficial. But yeah, they have docs. So I've got them open here. I don't know why I click that. If that loads. So this is going back to my demo, this is the API I was using. They essentially can give you a breakdown of what's going on. So you get an intensity for the date. So that's the 28th of January, 20th of January, 2018. The forecast was 266, index moderate. So they go low, very low, very low, low, moderate, high, very high. And they also give you a sort of a breakdown on the mix in there. So if you're like anti-nuclear as well, you could do some stuff to get rid of that. You'd obviously have to do your own processing, but it's a really cool, really cool API. I'd highly recommend just taking a look and having a play. But let me just go back to. Sorry, I'm not entirely sure where my mouse is. There we go. So going back to the presentation, if I can get it up. Cool. So the idea of my carbon intensity scheduler lambda is very wordy mouth. I couldn't think of anything cool to call it. So there's two components to this, or three. So Terraform kind of spins everything up, which is kind of box standard. But the actual stuff itself, there's two things. So there's an event bridge rule, and there's the lambda itself. So the rule will spark off every day or whatever time it's been told. So when you initially set this off, it's gonna spark in a minute. After that, it will hit the carbon intensity schedule. Just ignore this at the bottom for now. It doesn't really count. Or it does, but it's just to kind of demonstrate what you can be used for. That will go off to the National Grid's carbon intensity API and send some data back. And then it will do some processing and essentially just change the cron job on the rule. Really, really, really simple. And then the following day it'll run again, and it will keep doing that. So all of our other stuff which is listening to that can run. So if we, for instance, have to do a deployment every, Friday into our testing environment, but there's no specific time for it, why not hook that up into there and just deploy it at the best possible time? For God's sake, I need to find, there we go. So I've got this running already, and it has been running since Friday. So the lambda's here, and the rule should be, that's not the rule, that's the logs. The rule should be here, so we'll see if it loads when it's scheduled to run tomorrow. Tomorrow it's it should be running at 12:30 tomorrow, so that's the rule, and essentially that will just invoke our lambda via a trigger, so you should see that there. And then if we look at the logs over the last couple of days, we can kind of see, so that was the time I deployed it, 3:34, and if I go into there, it should, when it loads, kind of say the lowest forecast time, so this is sending a request off to the carbon intensity API. It gets a low request time of 3 a.m. the following day with a forecast of 126. And then it essentially just sets a new cron rule for that time and adjusts the event. I did trip over my own feet with British summertime and UTC because this is all in UTC and we're obviously in British summertime. So I got very confused and actually explained to Sarah and Kevin on the phone on Friday. I was like, there's a whole bug going on here, and it turns out there wasn't. I'm just an idiot. So that ran at 4 a.m. the next day, then 6:30, 1 o'clock, 3 o'clock. And then this is today's, which ran at 3:30 in the morning. And it's scheduled to run tomorrow at 12:30. So it's really simple. That's on GitHub, Bitbucket, one of them. There's a link. I'll share that at the end as well. I'm more than happy for people to just nick that, do whatever you want to do with it. If you want to use it, you don't have to, or just slate how bad the code is. That's fine as well. So the other pattern I wanted to talk about, and this will be quick, is, or it's kind of in a similar vein, but it's about deploying around in certain areas depending on the intensity of those regions. So we've got a map of Europe here and the 5 data centers that AWS provides us in Europe. I think I got Stockholm in the right place. I had to Google that. I wasn't entirely sure where it was. So I was like sat for ages thinking, is that the right dot? But we've got Ireland, London, Paris, Frankfurt, and Stockholm, hopefully in the right place. And yeah, there's this tool called Electricity Map. So they don't give us a forecast, but we do get live, when it loads, we do get live data with what's going on. So we can kind of see already France is extremely, extremely clean. They've got an intensity of 34 grams and grams. I don't know what the G stands for actually. But yeah, it's extremely clean, as is south central Sweden, and Stockholm should be there, around there. And then Germany, the UK, and Ireland are all a lot higher, like crazy high. But one of the things that might come about this is you may need to have data in the UK, but you could get away with having it deployed in Paris or Ireland, and you have to be confined to those three. So what will essentially happen is you'll have one of your sites running in Paris, and then the other one can almost change depending on the intensity level. So you can have a trigger and say, if it goes above 250, jump to the other one, unless that's also above 250, in which case stay and just go to the lowest one. So it's a way of redeploying your infrastructure around depending on the intensity at that current time. Same with Germany. I mean, if you remove, one of the things I noticed is if you kind of remove this nuclear aspect from France and from Sweden, suddenly the playing field is quite level. And actually places like Germany, which look dirty on the map, and from there it is, but if you actually remove that information, they are using a lot of solar panels, solar energy, wind, and etc. So it's a really cool way to think about your infrastructure, where it's deployed, and maybe do something smart to put it in different places depending on the intensity at that moment in time. Try to get back to my presentation. So those are just two patterns I came up with when reading this stuff. I had a lot of thoughts about a lot of different things, and I still have. Hopefully you guys have ideas. If you have, I'd genuinely love to hear them later on. And I would genuinely highly recommend you all think about doing something, or if you are like, you might think, well, what's the point? Genuinely, like, what is the point? If only I do something, I'm not going to make a huge difference. And I'm going to have to say this because it's about the climate, but there is a climate crisis going on. We all know that. We've all been lucky enough to be born into a world where we can enjoy it, but it's getting warmer. Sea levels are rising. There's wildfires everywhere at the moment. Things aren't great. So if we all make one small change, and some of them are actually quite cool and something nice to work on to our normal day job, we can make a huge difference. And that is the reason I'm here today, and that's what it is. And if that isn't enough of a motivation, you can go back to my initial idea, which was I was trying to save some money and ended up being sustainable. That's it. You're welcome, sir. So I was going to say I'll take questions downstairs at the Capgemini booth, but we have 20 minutes, so if anybody does want to ask any questions, I am going to caveat that with I'm not an expert, as I hope you've gathered, but I'm more than happy to have that discussion if anybody does. If not, there we go, we've got a guy with his hand up in the blue.
Have you thought about the impact of the actual programming languages used for the projects?
Can I ask you to re-ask the question?
Sorry. Have you thought about the impact of the languages that you choose for your projects? Because this is something that we have been looking at, and there is a massive difference whether you're going to go with, say, Java with Spring Boot versus, say, Rust and something else.
So I've only thought about it slightly in the Java space. So I'm a Java engineer. The code on that Bitbucket repo is written in Node, but it's probably awful. If you've got any Node engineers in here, I'm really sorry. I have looked at Quarkus, I know it's a framework, and it's meant to be more efficient than Spring, but that's all I know. I've kind of read the docs, and I wanted to, as I said earlier, I wanted to attend that talk. I went into the wrong room and didn't want to stand up, so I just sat down and listened. But yeah, there is definitely stuff online around that and what programming languages are meant to be more efficient than others. And I think it does come down to what you write and how you write it as well, to an extent, because you can make anything really inefficient if you want to. But there are definitely programming languages which are more efficient than others. That's a roundabout way of answering your question, but not answering it.
Have you the sort of intensity forecast was only for the UK? Have you found anything that might help for like worldwide? No,
I haven't. I did do some Googling. Admittedly, it was only like half an hour, 45 minutes. I genuinely couldn't find anything else. So I resorted to trying to find out what those carbon intensity people had done, which seemed to be looking at weather reports, kind of when it's going to be windy. There's a name for wind reports, and it's not called wind reports. It does have a cool scientific name. But looking at those things and then making predictions. So if you know, so for instance, if you're looking to deploy into, California, looking at their grid's makeup and what they've got, and then you can kind of work out what a forecast almost from that. But no, I haven't found anything. If you do find something, I would genuinely love to see it. So if anybody's got any resources, I'd be happy to receive those. at the back.
Thanks for that. It was really cool. Have you got any experience pitching this to any clients and how accepting they are of adding the extra effort into, say, an MVP? And what are the arguments for and against that you might have experienced? Because everyone loves doing stuff like this until it starts costing them money, right?
Yeah, I haven't pitched this to anyone apart from you guys. In terms of pros and cons, obvious con is it's going to take some time. It will. You know, people need to understand it and properly implement it. But yeah, loads of people have their objectives, including Capgemini. So if they have those objectives and they want to achieve those, then it's clearly worth the cost. And so it's another way that they can reduce emissions, as well as saying, we're using public transport, or people are working from home, or we're recycling. We've got more than 4 people to recycle now, so great. But yeah, doing things that we actually do as engineers as well. So in that sense, it might kick clients into gear and say, there's another way we can be more carbon neutral by X date.
Thanks for the talk. So I work within finance, and at the moment there's a lot of focus on ESG, which is a metric that's being used by lots of funds to see how social the funds are, and how, for example, things like, for example, having carbon neutrality / zero carbon emissions. So I just wanted to ask, you partly answered what the gentleman asked, where basically you've not really pitched it to other clients. But having said that, you mentioned about the Green, was it Green Foundation?
Yeah, the Green Software Foundation.
Okay. So is that actually like a UK-wide group, or is it actually bigger? And how is Capgemini involved in that?
We are not involved with them. I have registered to be involved with them, and they send me emails. But I've not actually done anything with them. Yeah, where's Green Software Foundation? You can all watch me make many typos now. Yeah, so these guys are a foundation set up by. Is that about going to take me anywhere? But yeah, essentially these guys, where I initially came, they do loads of stuff, loads of projects. Their Bitbucket repo and their resources are insane. There is so much on there. And to be honest, I didn't really know it was a practice until I saw this. I don't feel like I've answered your question, but yeah, as far as I'm aware, I don't think anyone in CAP works with them. I want to try reach out and see if we can do some stuff with them. That's my plan over the next couple of months. And yeah, just to get more involved and really have a dig through their resources and that kind of thing, and see where we can apply them in terms of bids, or stuff like banking, where you almost need to be on all the time. You can't really turn off. So where can we be greener with those things? Because it's hard really when you have to run 24/7 because you can't care about the intensity in the grid.
When choosing greener energy, did you notice any savings in cost?
No, AWS love to just take money off you. But one of the things I actually forgot to mention earlier is, so the big idea in using carbon intensity and choosing when to run when the energy is cleaner is those companies will obviously see a profit. There'll be a higher demand for their energy. And then when you're using coal and gas, if the demand goes down, suddenly there's less use of that. It's just supply and demand. So companies will then start investing more in solar panels, wind farms, because the supply always jumps up when those things are used and they're making more money. So the idea behind it is to kind of spur them on. It literally goes straight back to that meme. It's not on, sorry. I do believe, I've completely lost my bearings here. Here we go. I do believe saving money and being sustainable do go hand in hand. So yeah, eventually, people will, like, companies will make more money. So I guess they're making money, not saving money. And we might be paying the same, but it will make a big difference. Cool.
Do you have any ideas for particularly if you're like a junior developer and don't have any control over where things are deployed, about like how, I mean, other than like saying to more seniors, have we considered this? Are there other things that you've come across as maybe in your code writing practice or other tips you have?
So I think being a good dev is core to this. So making sure your code is well tested. You're not, you're limiting bugs, because if you write something and it's broken and it hasn't been tested well, somebody later on is going to have to fix that and write tests. So you've essentially used all of your compute resource plus deploying it, and then all of theirs and time. So being a genuine good engineer is the first step to being sustainable, really. And the good software practice and being sustainable genuinely go hand in hand. They are almost the same thing, from what I've learned. Cool. I don't see any hands, but the crew guy is running. Oh, he's going to the back. Cool. Yeah, guys, thank you for coming. I really appreciate it.